Hi all, welcome back to our YouTube channel. This video is a part 2 of the security services and mechanisms topic. So let's get started. In the previous video we covered all the security services. In this video we are going to cover some of the security mechanisms. Before going into the different security mechanisms, let's quickly have a look at its definition first. So a security mechanism is a process that is designed to detect, prevent or recover from a security attack. So as discussed in the previous video, a security mechanism helps us to answer the question how to implement security services which will help us achieve the security goals and safeguard us from the security attacks. So in security mechanisms, we have the following mechanisms. In this video, we are going to cover the first 4 security mechanisms that are encipherment, traffic padding, routing control and data integrity. Let's understand each of them properly. Let's start with the first one, which is encipherment. So encipherment is the use of mathematical algorithms to transform data into a form that is not readily intelligible. Here, not readily intelligible means that it is not understandable to a normal person. So in encipherment, we use a suitable algorithm which takes plain text as input and gives us ciphertext as an output. Here, the transformation and subsequent recovery of the data depends on an algorithm and encryption keys. So here we require one more thing apart from an algorithm, that is a secret key, also known as encryption key. In some algorithms, we might require more than one encryption keys. Here in the backend there is an encryption algorithm that is running which takes the plain text as input and gives the ciphertext as output. The same goes for the message recovery. There is a decryption algorithm in the backend which takes the ciphertext and secret key as input and gives plain text as output. This was all about encipherment. Let's move to the next, which is traffic padding. In traffic padding, we insert some bogus data into the data traffic. This avoids traffic analysis attack. Consider we have the following plain text. We first convert the plain text to ciphertext. Then we remove all the spaces between the words. Then we pad some bogus data before and after our ciphertext. So this is our ciphertext and these are the dummy data. Consider the following traffic of data. Here the green blocks present the actual ciphertext while the red block presents the dummy data padded to the traffic. So the example shown is just a part of the actual traffic. You can observe that there is no fixed pattern for the dummy data, which makes it difficult for Oscar to capture the actual ciphertext and perform a traffic analysis attack on that. In this way, the traffic padding security mechanism avoids the traffic analysis attack by padding the ongoing traffic with dummy bogus data, thus confusing Oscar to capture the real data. This was all about traffic padding. The next is routing control. In routing control, we select and continuously change different available routes between the sender and the receiver. It prevents from eavesdropping on a particular route. Let's call a Alice, Bob, Oscar example back to understand this better. Here Alice establishes a connection with Bob. However, Oscar also joins the connection and whenever Alice sends a message to Bob, Oscar also gets a copy of it. To avoid eavesdropping, Alice uses the routing control security mechanism and establishes new routes with Bob. Since Oscar is not eavesdropping on that route, messages sent by Alice are only received by Bob, thus preserving the confidentiality security goal. Now let's move to the last security mechanism for this video, which is data integrity. In data integrity, a checksum value is created using a specific process from the data itself. This ensures integrity of the message. Let's understand with the help of some graphics. Here, before sending the data to Bob, Alice needs to generate a checksum value. For this, she uses a checksum generator which inputs the data of the message and outputs the checksum value. Now Alice attaches the checksum value to the message and sends it to Bob. As we know, since Oscar is on the line, he also gets a copy. Now Bob uses the same checksum generator and generates the checksum value with the message that he has received. As you can see, both the checksum values are the same, that is 27, which implies that the data is not modified and verified using the checksum value. Now suppose Oscar modifies the data and sends the modified data to Bob. Bob, as previously, will calculate the checksum value. As you can see, the two values are different, which implies that the data is modified. Hence Bob will simply drop the message as it is modified by an unauthorized entity. So we can see that the checksum value helps to detect any modification in the data, thus achieving the integrity security goal. So these were the first 4 security mechanisms. We will cover the remaining 4 in the next video. So that's it for the video guys. Thanks for watching the video and if you have any doubts, please do let us know in the comment section below, and if you have found the video helpful, then do like and share the video with your friends and subscribe to Be The Best channel for more such videos. Meet you in the next videos of the CSS series. Bye bye.